In a residential garage sub-panel installation, it is generally required to have a 60-amp breaker serving as the main disconnect. This requirement stems from the National Electrical Code, often referred to as NEC, which mandates that a sub-panel have an overcurrent protective device or opt that is rated at the same amperage as the feeder cable supplying it. Consider a scenario where the feeder cable is rated for 60 amps. In this specific situation, the sub-panel's overcurrent protective device also needs to be rated at 60 amps. This ensures that the sub-panel is adequately protected from overcurrent situations. On the other hand, in commercial installations, a sub-panel typically does not require a main breaker if it is fed from a panel that already has a breaker protecting that sub-panel. The reason behind this difference lies in the fact that the main breaker located in the upstream panel serves the purpose of providing overcurrent protection for the downstream sub-panel. This upstream breaker effectively safeguards the sub-panel from any potential overcurrent conditions. However, there are exceptions to this general rule in commercial settings. For instance, if a sub-panel is situated at a separate location, or if it is fed through a receptacle outlet, then a main breaker is typically required within the sub-panel itself. This requirement exists to ensure that the sub-panel has its own local means of overcurrent protection in these specific scenarios. Now, let us examine the reasons for the discrepancy between residential and commercial electrical installations. Commercial buildings typically operate under more stringent electrical safety requirements compared to residential buildings. The NEC mandates that all electrical equipment must be installed in a manner that minimizes the potential risks of fire or electric shock. In residential installations, the use of a sub-panel overcurrent protective device offers an additional layer of protection against electrical faults. This added protection enhances the overall safety of the electrical system within the residential dwelling. Conversely, in commercial installations, the upstream breaker is generally considered sufficient to provide the necessary protection. Therefore, a main breaker in the sub-panel is often deemed unnecessary, as the upstream breaker already fulfills the overcurrent protection requirements. When undertaking any electrical work, especially when it comes to installing or modifying electrical systems, it is always advisable to seek the expertise of a licensed electrician. The qualified electrician possesses the knowledge and skills to ensure that the installation adheres to all applicable code requirements, including the NEC, and is safe for its intended use. An electrician can assess the specific electrical needs of the installation and recommend the appropriate solutions to meet those needs while maintaining electrical safety standards. Now let's delve into more specifics regarding sub-panels, breakers, and overcurrent protection, exploring the technical aspects in greater detail. A sub-panel, also known as a distribution panel, is a secondary electrical panel that receives power from the main electrical panel and distributes it to various branch circuits within a specific area, such as a garage or a section of a commercial building. Sub-panels are used to provide a convenient and organized way to manage and protect multiple circuits in a particular location. Breakers are essential components of electrical panels that are designed to protect circuits from overcurrent conditions. Overcurrents can occur due to various factors, such as short circuits, overloads, or ground faults. When an overcurrent occurs, the breaker trips, interrupting the flow of electricity to the affected circuit, thereby preventing damage to equipment and reducing the risk of fire. Overcurrent protection is a critical aspect of electrical safety. It involves the use of devices, such as breakers and fuses, to automatically disconnect a circuit when the current exceeds a predetermined safe level. Overcurrent protection devices are designed to respond quickly to overcurrent conditions, minimizing the potential for damage or injury. The National Electrical Code, NEC, provides comprehensive guidelines for the safe installation and operation of electrical systems. The NEC is a widely adopted standard in the United States and serves as a benchmark for electrical safety practices. It is updated every 3 years to incorporate the latest technological advancements and address emerging safety concerns. NEC contains numerous articles and sections that address specific requirements for various types of electrical installations, including sub-panels, breakers, and overcurrent protection. Some relevant NEC sections include Article 240, which covers the overcurrent protection, Article 408, which covers switchboards and panel boards, and Article 225, which covers outside branch circuits and feeders. These sections provide detailed guidance on the selection, installation, and protection of electrical equipment. In residential installations, the NEC typically requires that sub-panels have a main breaker that is rated at the same amperage as the feeder conductors supplying the panel. This requirement ensures that the sub-panel is adequately protected from overcurrent conditions and that the feeder conductors are not overloaded. The main breaker in the sub-panel serves as a local disconnect means, allowing the entire panel to be energized for maintenance or repairs. In commercial installations, the NEC may allow for exceptions to the main breaker requirement in sub-panels, provided that certain conditions are met. For example, if the sub-panel is fed from a feeder that is protected by an upstream breaker, the main breaker in the sub-panel may not be required. However, the upstream breaker must be sized appropriately to protect the feeder conductors and the sub-panel from overcurrent conditions. Additionally, the NEC may require a main breaker in the sub-panel if the sub-panel serves a specific type of load, such as a motor or a generator. These requirements vary depending on the specific application and the electrical characteristics of the load. When selecting breakers for a sub-panel, it is essential to consider several factors, including the amperage rating of the circuit, the type of load being served, and the interrupting rating of the breaker. The amperage rating of the breaker should match the ampacity of the circuit conductors to ensure that the conductors are protected from overloads. The type of load being served may require a specific type of breaker, such as a ground fault circuit interrupter, GFCI, breaker for circuits serving wet locations. The interrupting rating of the breaker should be sufficient to safely interrupt the maximum available fault current at the point of installation. It is also important to ensure that the breakers used in the sub-panel are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or UL. Listing and labeling indicate that the breakers have been tested and certified to meet applicable safety standards. When installing a sub-panel, it is crucial to follow all applicable electrical codes and regulations, including the NEC and local amendments. The installation should be performed by a qualified electrician who is familiar with the requirements for sub-panels and overcurrent protection. The electrician should ensure that the sub-panel is properly grounded, that the conductors are sized correctly, and that the breakers are installed in accordance with the manufacturer's instructions. Regular inspection and maintenance of sub-panels and breakers are essential for ensuring the continued safe operation of the electrical system. Sub-panels should be inspected periodically for signs of damage, corrosion, or overheating. Breakers should be tested regularly to verify that they are functioning properly and that they trip when subjected to an overcurrent. Any damaged or malfunctioning component should be replaced promptly. In addition to the NEC, other standards and guidelines may apply to sub-panel installations depending on the specific application and location. For example, the National Fire Protection Association or NFPA publishes standards related to electrical safety, such as NFPA 70E, which covers electrical safety in the workplace. These standards provide guidance on safe work practices and procedures for electrical installations. Furthermore, local built-in codes and regulations may impose additional requirements for sub-panel installations. It is important to consult with local authorities to determine the applicable codes and regulations in a specific jurisdiction. Now, let's consider some specific scenarios involving sub-panel installations and overcurrent protection. In a residential garage, a 60-amp sub-panel is often used to provide power to various circuits, such as lighting, receptacles, and power tools. The 60-amp sub-panel is typically fed from a 60-amp breaker in the main electrical panel. In this scenario, the sub-panel should have a 60-amp main breaker to provide overcurrent protection for the panel and the feeder conductors. The branch circuits in the sub-panel can be protected by 15-amp or 20-amp breakers, depending on the ampacity of the circuit conductors and the type of load being served. In a commercial building, a sub-panel may be used to provide power to a specific area, such as an office suite or a retail space. The size of the sub-panel and the amperage rating of the breakers will depend on the electrical load requirements of the area being served. In some cases, the sub-panel may be fed from a feeder that is protected by an upstream breaker in the main electrical panel. In this scenario, the sub-panel may not require a main breaker, provided that the upstream breaker is sized appropriately to protect the feeder conductors and the sub-panel from overcurrent conditions. However, it is important to consult with a qualified electrician to determine the specific requirements for the sub-panel installation. In industrial facilities, sub-panels are often used to provide power to machinery, equipment, and lighting systems. These sub-panels may be subject to more stringent requirements than those in residential or commercial buildings. For example, industrial sub-panels may require additional overcurrent protection devices, such as fuses or circuit breakers with higher interrupting ratings. They may also require special enclosures to protect the equipment from harsh environmental conditions. The installation and maintenance of industrial sub-panels should be performed by qualified electricians who are familiar with the specific requirements for industrial electrical systems. In summary, sub-panels are an important part of electrical distribution systems, providing a convenient and organized way to manage and protect multiple circuits in a specific area. Breakers are essential components of sub-panels that are designed to protect circuits from overcurrent conditions. Overcurrent protection is a critical aspect of electrical safety, and it is essential to follow all applicable electrical codes and regulations when installing and maintaining sub-panels and breakers. Consulting with a qualified electrician is always advisable to ensure that the installation meets all applicable code requirements and is safe for use. Remember to use appropriately sized conductors. Remember to follow the manufacturer's instructions. And remember to properly label your panel after you are done with the installation. A licensed electrician can help ensure compliance with local electrical codes and safety standards, but to help illustrate this concept, let us look at a few more examples. Example 1. Residential detached garage. A detached garage sub-panel, even in a residential setting, might have slightly different requirements compared to an attached garage. The NEC typically requires a disconnecting means in a detached building, which could be a main breaker in the sub-panel or a separate disconnect switch. This is for safety, allowing a way to easily de-energize the entire garage at its location. Example 2. Commercial office space. In a commercial office space, a sub-panel feeding multiple cubicles with computers and lighting might not need a main breaker if the upstream panel provides adequate overcurrent protection. The key here is the coordinated design, ensuring the feeder conductors and the sub-panel itself are protected by the upstream breaker. Example 3. Industrial Motor Control Center. An industrial motor control center, which is essentially a large sub-panel for motor control, typically has individual breakers or fuses for each motor. While it might have a main breaker, its primary protection comes from the individual overcurrent devices protecting each motor circuit. The main breaker mainly serves as a disconnecting means for the entire control center. Some points to remember are, firstly, local codes always prevail. While the NEC is a widely adopted standard, local jurisdictions can have amendments or additions. Always check local codes before starting any electrical work. Secondly, overcurrent protection is a system. It's not just about having a breaker. It's about coordinating the sizes of conductors, breakers, and the equipment they protect. Thirdly, ground fault protection is essential. GFCI protection is crucial, especially in residential garages and any area where moisture is present. Fourthly, arc fault circuit interrupters or FSIs are increasingly important. FSIs are designed to protect against arc faults, a common cause of electrical fires. Their use is expanding in residential installations. Lastly, regular inspections are important. Periodically inspect your electrical panels for any signs of damage, overheating, or loose connections. These are dangerous and should be addressed immediately.